So now let's figure out what the derivative of inverse sine is. So this is a little bit of math enrichment. So if I have y equal inverse sine, I can take the sine of both sides. So I get this. Oh, look at that. I can take the derivative implicitly. So if I take the derivative with respect to x on both sides, from here I get cosine of y, and I know I need to multiply times the derivative of the angle, y prime. And the derivative of x with respect to x just means you do the power rule on the x, and that's 1. Okay, so solve for y prime. It's 1 over cosine of y. You know this is true for any angle, right? So I'm going to rewrite cosine as the cosine of y, as the square root of 1 minus sine squared, just using this. So since I know sine of y is equal to x, I'm just going to replace that with x. So I get y prime is 1 over cosine of y. Using what I have here, it's 1 over the square root of 1 minus x squared. Wow, okay. So I'm not going to go do the other ones, but these are what you get to memorize. So arcsine and arctangent will continue to show up through the rest of this school year. So make sure you know it. Here we go. And so this is just giving you the chain rule, which you kind of know, right? So y prime. So the derivative of arcsine is 1 over the square root of 1 minus stuff squared. And then we go take the derivative of stuff. So we multiply by 3x squared. So be careful with that. Okay, so let's go do the other one. So the derivative of arctangent is 1 over 1 plus stuff squared. So I put the 4 in. And then I multiply by the derivative of x to the 4th, which is 4x cubed. So I'm going to rewrite these and simplify. So 1 minus x to the 6th, 3x squared. So be careful when I'm taking the derivative. You're not taking the derivative of x to the 6th, but the original x cubed angle. And again, this is 1 over 1 plus x to the 8th. And I didn't take the derivative of x to the 8th. I took the derivative of the original angle. So 4x cubed. And you could put the 4x cubed and the 3x squared over on top. It doesn't matter. Okay, let's do it again. So y prime 1 over the square root of 1 minus stuff squared. Derivative of the e to the 3x would be e to the 3x times a 3. And then minus the derivative of arctan, 1 over 1 plus stuff squared, and that's sine of 4x. Now it's our turn to take the derivative of sine of 4x, which is cosine of 4x times 4. So let's just make sure that you know what this simplifies to. It's not much, but I want to make sure you get the exponents correct. So this 3e to the 3x is in the numerator. And then down here, you remember you multiply those exponents. So I get e to the 6x from there. And then minus 4 cosine of 4x. And then 1 plus, and this sign could be squared like that if you wanted to write it that way, right? It works the same way. All right, how about this next one? So this this radical turns into a big 1/2. So if I'm going to start to take the derivative, I bring the 1/2 down, and I get to the negative 1/2. Carry the inside function along. Now I'm ready to take the derivative of the arcsine, which is 1 over the square root of 1 minus stuff squared, and that would be the 4x. Now I multiply by the derivative of the 4x, which is 4. Minus, now I'm taking the derivative of arctan, 1 over 1 plus stuff squared, so that's root x squared, and then I have to multiply by the derivative of root x, which is 1/2 x to the negative 1/2. So let's see what I can do with this. So I see this 4, try to get a different color here, this 4 and this 1/2 will all give me the number 2, right? This isn't a square root in the denominator, so I'll put that down there. And then I've got this square root thing. And then if I wanted to square it, I could say that's 16x squared. And let's do this kind of a little bit of stumping over here. So I'll pull that number 1/2 in the front. I have 1 over 1 plus, what's root x squared? That's just an x, right? So let's just write that. And then times a 1/2, and then the root x goes in the denominator. So just so you can see what it looks like. All right, one more. Derivative of arctangent is 1 over 1 plus stuff squared times the derivative of y squared, which would be 2y, y prime, equal, okay, derivative of arc sine, 1 over 1 minus stuff squared. The stuff is root x. And then I have to multiply by the derivative, so that's 1/2 x to the negative 1/2. And then move to the last term, I get a plus a 12 y cubed times y prime. So looking for my y prime terms, whoops, there's one and there's one. Oh, I don't need to solve for y prime, silly me. Oh, no, it is, silly me. Okay, so let's put them on this side. So I'd have 2y, y prime over 1 plus y to the 4th minus 12y cubed, y prime equals, and then let's just kind of fix this up. This root squared would be just an x, and I'd have 1/2, 1 over root x. All right, so then I'm going to factor out a y prime and divide by that stuff, right? So I would get, oh boy, I'm going to need some more room, aren't I? So let's put it up here. So I'm out of paper, out of a page down there. Okay, so... okay, so factoring the y prime out of the left-hand side. So here's my y prime, and there's my y prime, right? So I'd have y prime, and then 2y, 1 plus y to the 4th, minus 12y cubed, equals all of this. So 1 minus x, 1/2, right? All of that's like, put it all together in the denominator. Now I'm going to divide by that big bad boy, right? Eraser. So I get y prime equal, so this is going to be very big, ugly, complex fraction, right? All over this. So 2y, 1 plus y to the 4th minus 12y cubed. That is pretty ugly, but there it is, y prime.